This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky.
For half a century, the European Southern Observatory has showcased the splendor of the universe. Starlight rains down on the Earth. Giant telescopes catch the cosmic photons and feed them to state-of-the-art cameras and spectrographs. Today's astronomical images are very different from those of the 1960s. When ESO began back in 1962, astronomers used large photographic glass plates. Not very sensitive, imprecise, and hard to handle. What a difference today's electronic detectors have made. They catch almost every photon. The images are available instantaneously, and, most importantly, they can be processed and analysed by computer software. Astronomy has truly become a digital science.
ESO telescopes use some of the largest and most sensitive detectors in the world. The VISTA camera has no less than 16 of them, for a total of 67 million pixels.
This huge instrument catches infrared light from cosmic dust clouds, newborn stars, and distant galaxies. Liquid helium keeps the detectors at minus 269 degrees. VISTA takes an inventory of the southern sky, like an explorer surveying an unknown continent.
The VLT Survey Telescope is another discovery machine, but this one works at visible wavelengths.
Its camera, called OmegaCAM, is even larger. 32 CCDs team up to produce spectacular images with a mind-boggling 268 million pixels. The field of view is 1 square degree, 4 times as large as the full moon. OmegaCAM generates 50 gigabytes of data every night. And these are just gorgeous gigabytes.
Survey telescopes like VISTA and the VST also mine the sky for rare and interesting objects. Astronomers then use the sheer power of the VLT to study these objects in exquisite detail. Each of the VLT's 4 telescopes has its own set of unique instruments, each with its own particular strengths. Without these instruments, ESO's giant eye on the sky would be, well, blind.
They have fanciful names like Isaac, Flames, Hawkeye, and Symphony. Giant high-tech machines, each the size of a small car. Their purpose? To record the cosmic photons and recover every possible bit of information.
All of the instruments are unique, but some are a little more special than others. For example, Mako here and Symphony use the VLT's adaptive optics system.
Lasers produce artificial stars that help astronomers to correct for atmospheric blurring. NACO's images are as sharp as if they were taken from outer space. And then there's MIDI and AMBER, two interferometric instruments. Here, light waves from two or more telescopes are brought together as if they were captured by one giant single mirror. The result? The sharpest views you can imagine.
But astronomy is not only about taking images. If you're after the details, you have to dissect the starlight and study its composition.
Spectroscopy is one of astronomy's most powerful tools. No wonder ESO boasts some of the world's most advanced spectrographs, like the powerful X-shooter. Images carry more beauty, but spectra reveal more information. Composition, motions, ages. The atmospheres of exoplanets orbiting distant stars. Or newborn galaxies at the edge of the observable universe.
Without spectroscopy, we would just be explorers staring at a beautiful landscape. With spectroscopy, we learn about the landscape's topography, geology, evolution, and composition.
And there's one more thing. Despite its serene beauty, the universe is a violent place. Things go bump in the night, and astronomers want to catch each and every event. Massive stars end their lives in titanic supernova explosions. Some cosmic detonations are so powerful that they briefly outshine their parent galaxy, flooding intergalactic space with invisible high-energy gamma rays. Small robotic telescopes respond to automatic alerts from satellites. Within seconds, they swing into position to study the aftermaths of these explosions. Other roboscopes focus on less dramatic events, such as distant planets that pass in front of their mother stars. The cosmos is in a constant state of flux. ESO tries not to miss a single heartbeat. Cosmology is the study of the universe as a whole, its structure, evolution, and origin. Here, catching as much light as possible is of the essence. These galaxies are so far away that only a handful of photons reach the Earth. But these photons hold clues to the cosmic past. They have travelled for billions of years. They paint a picture of the early days of the universe. That's why big telescopes and sensitive detectors are so important. Over the past 50 years, ESO telescopes have revealed some of the most distant galaxies and quasars ever observed. They even helped to uncover the distribution of dark matter, the nature of which is still a mystery. Who knows what the next 50 years will bring?
This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.